All right, welcome to the XPlainer. Today, we're tackling something huge. We're diving headfirst into a really radical challenge to one of the most fundamental ideas in all of physics. We're going to explore the argument that the photon, the basic particle of light, might not actually be a particle at all.
Let's just jump right in with the core claim from the source material. The photon is a ghost, built of math, not matter. Whoa. I mean, that's a provocative statement, right? It's the central idea we're going to unpack today, and it suggests that this thing we call a photon might not be a physical object in the way we've always imagined. Okay, so our first section is called a ghost built of math, and that's exactly what we need to figure out. What on earth does that even mean?
So let's just ask the question straight up. You and I, we were all taught in school that light is made of these little packets of energy, these photons. But what if that whole picture, as useful as it's been for a century, is just wrong?
So here's the core argument. Now, nobody's saying light isn't real, okay? The argument is that the photon, the particle itself, doesn't really exist on its own. Instead, it's what scientists call a model artifact. You can think of it as a really useful character we invented because it makes our math work out perfectly. It's a key player in our story about the universe, but maybe not a real actor on the stage.
All right, let's move on. Section 2, object versus model. And honestly, this distinction is everything. It's the key to this entire idea.
So, on the one hand, you've got the picture we all know and love. A photon is a discrete object, like a tiny bullet of light that you can isolate and track. But on the other hand, you have this totally different radical idea. A photon is just a name. It's a mathematical description, a label we put on an interaction that we observe. It's defined only by its effect.
So what exactly is a model artifact?
Well, the formal definition says it's a mathematical construct that comes from fitting a formula to a repeatable output. In plain English, it means we see the same result happen over and over again, and we invent a thing in our formula to explain that result. The crucial part is, we never actually see the thing itself, just the consistent outcome.
Okay, moving on to section 3, the footprint, not the person. And this is where it all starts to click, because the analogies here are just perfect. So check this out. Premise number 1. From the formal audit of this idea, we have never, and I mean never, directly seen a photon just floating around by itself. Every single time we measure a photon, what we're really measuring is an interaction. A little click on a detector, an electron getting excited, and from that we infer a photon must have been there. We're only ever seeing the aftermath, not the event itself.
Yeah, exactly. To put it really simply, they're not seeing the actual light. They're just seeing the result of what light did. It seems like such a subtle difference in wording, but believe me, it is a profound one.
And that leads us right to the second big point. We basically define the photon backwards. Think about it. A sensor goes click, and only then do we say, oh, that must have been a photon. The argument is that before that click, there was no particle. There was just an electromagnetic wave, a field of possibilities. The measurement itself is what creates the particle's identity for us.
Here's that killer analogy. It's like calling a footprint a person. I mean, yeah, something definitely made the footprint, obviously. But the footprint isn't the person. And in the same way, that click on the detector isn't the photon. It's just the evidence that something interacted right there at that spot.
Okay, now we get to section 4. It's not just photons. And this is where things get really wild. Because this isn't just some weird idea about light. It might be pointing to a much bigger pattern, maybe even a fundamental flaw in how we think about physics.
So let's talk about the graviton. This is the hypothetical particle of gravity, right? The little messenger that's supposed to carry the gravitational force. It was basically invented to make gravity fit nicely into the standard model. But there's one tiny problem. No one has ever seen one.
And here's another fantastic analogy from the source material. Trying to say gravity is a particle is like trying to catch a hug in a jar. I mean, it just doesn't make sense, right? Gravity is a field. It's the shape of space-time. How do you chop that up into little bits? You just can't put an interaction in a bottle.
And when you put them side by side, the pattern is just crystal clear. For both the photon and the graviton, we seem to be making the same logical mistake. We're taking the effect, a click on a sensor, the pull of gravity, and we're calling it the cause. We're taking a continuous field, whether it's the electromagnetic field or the gravitational field, and we're trying to force it into being a little object. An interaction gets turned into an identity. It's the same flawed thinking, twice.
So you might be thinking, okay, this is all interesting philosophy, but is it science? Well, it is. And that brings us to section 5, how to catch the ghost. Because for any scientific claim to be valid, there has to be a way to prove it wrong.
And this idea is absolutely falsifiable. The whole thing falls apart if scientists could do any one of these three things. Number 1, directly track a single photon's complete unbroken journey from A to B. Number 2, show that it has a clear identity before it hits a detector. Or number 3, figure out a way to produce a signature of a photon that doesn't depend on a detector at all. If you can do any of that, the ghost is caught. But here's the thing. So far, nobody has been able to do it. Not even close. And until they can, the argument holds. The photon remains this incredibly useful, predictive, and, yeah, elegant concept. But it's a ghost that lives inside our math, not necessarily out there in the real world. And that leaves us with a pretty mind-bending question to chew on. Okay, so the photon is a model, the graviton is a model. What else? What else out there that we take for granted as being solid and real is just another ghost in the math?